listen to this because it's a massive shift reshaping tech right now. The absolute most important AI in your life, just 5 years from now, it is not going to live in some massive data center. No, it won't even need the internet, and it certainly won't be pinging your data across the globe. It's going to live completely offline, right on your local hardware, literally in your pocket. Welcome back to Trend Guards. In today's explainer, as always, we're cutting through the hype and looking at the verified facts. Today, we're tracking a monumental shift, the great migration of AI from the cloud straight to your devices. Okay, let's dive into this. Because, for years now, using AI has basically meant exactly one thing, right? Your words, your photos, your questions, they all get shipped across the internet to this massive warehouse packed with ridiculously expensive GPUs. It gets processed on a server, and then the answer gets shipped all the way back to you. Every single time you ask a question, it's making that entire round trip. And honestly, that architecture creates some pretty massive bottlenecks. First off, there's inherent latency. You're just sitting there waiting for the network. But more importantly, the cost is absolutely astronomical for these companies. Running massive data centers, cooling huge server farms, fighting over global GPU shortages, it literally means every time you generate a text or an image, a company is burning real electricity and expensive server time. Plus, from a privacy standpoint, your most personal thoughts are ending up on a server you'll literally never see. But based on the verified industry roadmaps we're seeing right now, that era of cloud-only AI, it's quietly coming to an end. To really understand how we get there, we have to look at how computing architecture is fundamentally swinging right back toward you, the user. Think about the last decade. The whole story in tech was that everything moved to the cloud. Your phone was kind of just a dumb window into a giant server's brain. But now, the pendulum is swinging right back to the device in your hand. The industry calls this on-device AI, or edge AI, and what's changed is pretty remarkable. AI models have finally gotten small enough, and the chips inside our consumer devices have gotten smart enough to run real, actual intelligence locally. We're literally transitioning from an era where these models demanded hundreds of gigabytes of server memory to a reality where that exact same capability is compressed to fit onto a standard smartphone's 8 GB RAM chip. It's a perfect storm. Small enough intelligence has finally met smart enough consumer devices. Now, this shift isn't just happening because it's some cool technical trick. It's being pushed by 3 very real objective forces that make it totally inevitable. Number 1 is privacy. For highly regulated industries, think healthcare or finance, or honestly just for your own personal use, shipping sensitive data to a cloud server is often a deal breaker. On-device AI means a doctor can analyze medical records on a tablet completely within HIPAA compliance, because the data literally never leaves that local hardware. Force number 2 is speed and availability. Cloud AI always has built-in latency, and if you hit a dead zone, it's completely useless. Edge AI, though, it operates instantly. You can do real-time voice translation on a subway or an airplane with zero network connection. But the third force, this one is the quietest and probably the most powerful. It's cost. Running those cloud data centers costs absolute fortunes in energy and API calls. By pushing AI to the edge, tech giants are financially incentivized to offload those heavy compute costs directly onto the battery and the processor that you already bought and own. When you align privacy, speed, and cost, yeah, the market is definitely going to move.
So how are they actually pulling this off? Let's pop the hood and demystify the real hardware and software making this possible, free of all the marketing hype. And this brilliantly illustrates the hardware side. Look at the difference between a CPU and an NPU. Now, you're probably super familiar with a CPU. Think of it as a generalist mathematician. It's great at running your operating system or your web browser efficiently, but running AI, that requires matrix multiplication, doing thousands of simple calculations all at the exact same time. If your standard CPU tries to do that, it hits severe thermal throttling. Basically, your device gets incredibly hot and your battery is dead in an hour. Enter the NPU, or Neural Processing Unit. You can think of the NPU as a massive array of incredibly fast calculators built exclusively to do parallel AI math. This dedicated silicon processes AI tasks with intense power efficiency. It is literally the only reason modern smartphones don't just melt in your hands when they run local intelligence. But on the software side, engineers still have this massive problem. How do you fit a giant AI model onto that hardware? A standard phone has really tight memory limits, right? Meanwhile, a frontier AI model usually needs terabytes of space. Well, to solve this, they use a clever technique called quantization. Basically, an AI model stores its knowledge as numbers or weights, usually in super high precision. Quantization strategically drops the precision of those stored numbers. It's exactly like taking a massive high-res raw photograph and compressing it down into a much smaller JPEG file. Sure, you lose a tiny bit of image fidelity, but suddenly the file is small enough to fit seamlessly onto a consumer device's memory, and it doesn't severely impact the actual output.
And the other major software trick is called distillation. This is a process where engineers take a massive, cutting-edge frontier model, one that might have 1 trillion parameters, and they use it as a teacher for a much smaller, highly efficient student model. The giant model literally trains the small one to directly imitate its behavior, its reasoning, and its answers. It passes down only the most crucial patterns and strips away all the unnecessary fluff. Put it all together and you get this incredibly practical ecosystem. Software techniques like quantization and distillation shrink the models down, while that advanced NPU hardware we just talked about ensures the device can actually run those compressed models smoothly. Now that this tech is totally viable, we're watching a massive industry race play out in real time. The balance of power is literally shifting from the big cloud giants directly to device makers. And if we break down the confirmed strategies of the major players, you can see some very distinct approaches. Apple, they're playing the pure ecosystem privacy angle. They are heavily focused on private by design architecture, deeply integrating smaller AI models right into their operating systems so processing stays local, keeping your data far away from liability-heavy servers. Google, on the other hand, is executing a hybrid game. They're using their massive Android scale to put small versions of models like Gemini Nano directly onto phones while keeping their massive heavy lifting models back in the cloud. Meanwhile, Qualcomm is aggressively driving the silicon war. They are pushing NPU performance, which is often measured in TOPS, or trillions of operations per second, to power this whole next generation of consumer hardware across a bunch of different brands.
And we really need to be precise here. This migration is definitely not just about smartphones. The tech industry is currently pushing a massive hardware refresh called the AI PC wave. PC manufacturers are actively baking NPUs right into laptop motherboards as we speak, giving local AI software a native environment to run efficiently without completely tanking your battery life. And it goes even further. Automakers are basically turning vehicles into rolling edge AI devices. Think about it. For advanced driver assistance systems, a car needs instant, completely offline intelligence. If a self-driving car is doing 70 miles per hour and needs to detect a pedestrian, it literally cannot wait for a 200 millisecond round-trip server ping. That latency is a life or death metric. It absolutely requires localized AI.
So let's do a quick reality check here regarding the physical ceilings of your local hardware, especially when it comes to memory and heat dissipation. The cloud isn't actually dying, it's just specializing. The true computing architecture of the future is going to be hybrid. Think of your local device as a really smart gatekeeper. For like 90% of your daily needs, things like live transcription, summarizing a quick email, or sorting your photos, your local NPU handles all of that instantly and entirely privately. But when you ask the system to do some massive, complex reasoning, like coding a complex software application or analyzing a huge database, the device quietly recognizes its own limits and routes that specific request up to the cloud for the heavy lifting. And this tiered routing, it's designed to be completely invisible and seamless to you, the user. Finally, as part of our mandate here at TrendGuards to look at the real-world impact of these shifts, we really need to talk about the brand new risk profile this architecture creates. This quote hits the nail on the head. Yes, the upside is highly functional. You get a truly private AI that costs you absolutely nothing per query. But having an always-on AI that understands everything you do, reads your texts, and analyzes your screen, it means every bit of your personal context is concentrated in one single physical object. You know, the cloud had privacy problems because your data was sitting vulnerable on a distant corporate server. But the edge has intimacy problems. If an AI understands your entire life context, that specific phone or laptop becomes a massive single point of failure. Think about it. If you leave that device at an airport, or if it gets hacked by a malicious actor, they aren't just getting a few individual files. They are gaining access to a profile that intimately understands exactly who you are. So, based on the current verified industry roadmaps, here is exactly what happens next. First, the NPU is going to become the new headline hardware spec. Very soon, consumers will be shopping for devices based on local AI performance, the exact same way they used to shop for megapixel counts on a camera. Second, that hybrid split between the cloud and the device, it's going to become totally invisible, completely managed autonomously by your operating system. And third, on-device privacy is about to become the primary marketing battleground. The tech companies that can credibly prove they cannot see your local AI data and that your intelligence stays entirely yours, they're going to have a massive competitive advantage in this era. We've looked at how this local tech actually works, why the economics make it totally inevitable, and how power is shifting right out of the centralized cloud and into your hand. But the really big question isn't just about hardware specs. It's about our relationship with this tech. The skill of the future won't just be knowing how to use AI. It's going to be deciding exactly how much you are comfortable letting a machine know. So I have to ask you, would you trust an on-device AI that knows absolutely everything about you, or does having that much intimate intelligence sitting directly in your pocket cross a fundamental line? Let us know your take. I'm your host, and as always, we'll keep tracking the tech industry shifts by analyzing the verified source material right here at Trend Guards. Thanks for watching, and I'll see you in the next explainer.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.